before you forget, just interrupt me anytime, and I'll be happy to answer them. This is about the more advanced features of the D programming language. We're going to skip all the basics. I'm kind of one of those guys who thinks that it's the small things that make a language a pleasure to use. I think Apple's kind of proved that point. But this topic, this talk isn't about the small things. It's about the things that are above and beyond kind of the cool stuff, the stuff that's out there. So, basically, are you bored with the usual introductory stuff, expression statements, the endless debate about core strings vs library strings? Okay, we're going to get into the cool stuff, which is for each loops, lambda functions, mixins, tuples, scope guards, lazy arguments, and static ifs. And for all the C++ experts, yes, you can do all of the stuff in C++. By hook or by crook, one way or another, you can get it done. But sometimes the result is so awful you don't want to really use it. And D tries to make this stuff nice. Okay, well, let's start with something not too far advanced, looping. Let's look at how loops look in C. A typical function and a typical loop, and you pass an array into foo and you loop over it through the elements of the array. You pull values out of the array and you do something with them. And this kind of code you see over and over in C code. I write a lot of code like this in C. And well, it's pretty much wrong most of the time. The declaration of I should be a size t, not an int. Array is not checked for overflow. 10 may not be the actual array dimension. It may be more efficient to step through the array with pointers rather than indices. The type of the array may change, but the type of value may not get updated. Crashes if array happens to be null, and it only works with arrays and pointers. So that's a typical C loop and a typical problems loop. In C++, the usual way to do this is to use, instead of an array, use std called vector. And you write the loop like this using the STL iterators. And, well, it's a lot better, but it's not perfect. It still doesn't do the type deduction of what the value is. So the type of the array may change, but the type of the value may not get updated. And its worst fault is it's just too darn much typing. I mean, that is an awful lot of typing with special characters and angle brackets. And in fact, some of the angle brackets actually are missing somewhere.
Yeah, and you're copying the vector on the way in.
Yeah. Yeah, the angle brackets actually are in my HTML source, but HTML thought they were a tag and removed them. So imagine that there are the angle brackets in there, which makes it even look worse than it actually looks on here. In D, we have a thing called for each loop, which we pass in an array. We can loop over the array, extracting value one at a time through there, and then we do something with value. And you see that's it is correct. There are no hidden weird bugs in it. And it's very little typing. It's actually even less typing than the C version. Okay? Some of the features of this are the correct loop index type is selected based on the type of array. Arrays carry with them their dimensions, so for each is guaranteed to step through the loop the correct number of times. You're not going to get a mismatch with the array dimension and the array. The implementation decides if pointers will do a better job than indices based on what you're compiling for and the quality of the implementation. The type of value is inferred automatically from the type of the array. So if you change the type of the array, your loop is going to change automatically, and you don't have to worry about implicit casting screwing everything up. arrays have 0 length, so it won't crash if you happen to pass null for your array. And not only does it work for arrays, it works with any collection type. So it's a pretty generic way of doing things. If you made foo into a template, it would be then like a template algorithm, or like an STL algorithm. So much for loops. The next thing is scope guards. Now, this clearly can be done in C++ because Andre has implemented it in C++. It's a series of macros and templates. And what scope guards do, but suppose they help with transaction processing. Suppose I have a function ABC that returns a completed transaction. And the transaction is composed of 2 parts, do foo and do bar, and they both need to succeed or neither should happen. Okay? So if do foo throws an exception, I'm okay, nothing happens. If do bar throws an exception, somehow I've got to unwind do foo because I can't have one of these succeed and not the other. They have to either both succeed or neither of them succeed. And this is fundamental to transaction processing. Okay, to support this, we assume that do foo has a do foo unwind operation and do bar has an unwind, or an undo for it too. The traditional C++ approach uses RAII, which is resource acquisition is initialization. And what that does is when things go out of scope, the destructor gets called, and we can latch onto it by creating ourselves an extra class called, we'll call it foox, which is a wrapper for foo, and it has a commit, which says, do I need to unwind foo or not? And in the destructor, if it's not committed, I undo it. And so our transaction function will look like I create a new foox instead of foo, do bar. If bar succeeded, I go commit equals true, and that prevents the foo unwind from happening in the destructor, and then I return my completed transaction. So that's one way to solve this problem. The other way is the Java approach, which is try finally, where we do foo, and if that fails, well, we're okay, we don't have to worry about that. Inside of, then the next thing we do is we have to put do bar inside of a try block. Because if it fails, we want to catch the failure, undo foo, and rethrow the exception. And it's kind of hard looking at that and realizing that that's what's happening with this.
So where's the finally?
What?
Where's the finally?
Well, it's in the catch, really.
Okay.
It's the try-catch finally thing. I should have written it that way. Good catch. Okay, both of these approaches work. It's an important thing to realize, but they all have problems. The RAII approach involves the creation of dummy classes, and you have to move some of the logic out of your function. So your logic gets spread out over your function and this dummy class that you created. The try-catch approach is wordy even with a simple example. Try writing it if there are more than 2 components of the transaction. So it doesn't scale very well if you have multiple things that have to be unwound, or that all have to happen or be unwound. Then you wind up with all these nested try-catches in a rather horrific looking mess. So the solution is to introduce a statement called a scope failure, and what happens is I call do foo to do my function. And then this scope failure means that when I hit the end of the scope, if I hit that end of the scope due to a failure, then I execute this code here. Thus, this is actually gets all my logic where I'm thinking about the logic. Because I put my scope failure code right next to my do foo code, so right where I'm writing the code, I put its unwind code, goes right next to it, instead of being in another class someplace else, or buried in a catch clause somewhere, 30 lines down in your code. I can put the two logically right next to each other, which makes it much easier to look at and verify that, yes, I did it right. It scales up to more complex ones because you just simply do them iteratively. Yes, sir?
Is the transaction part of the scope semantics, or is that just part of the example? Transaction
In this?
Yeah.
Oh, that just simply constructs our transaction based on the results.
Okay,
Of
so
the
that doesn't
components.
need to be there for the scope failure?
No, it doesn't really need to be there. It's just that this transaction consists of 3 parts, and all those 3 parts must succeed. Then I can build my transaction. Yes, sir.
So I know you said that everything you're showing here can be done in C++, and I guess I'm just pointing that out, but it seems like all this scope construct is basically, it's totally equivalent to having just a generic RAII object that's taking a lambda expression that will be its destructor. That's basically what you have here, right?
Well, that's, I believe, how Andre's scheme to make it work in C++ works.
Right. I mean, it'd be slightly syntactically different, but that's basically what we have.
Okay, but I think you'll see that the problem with that is you can put any code in here.
Uh-huh.
With the C++ approach, you have all these restrictions on what you can do for the scope failure because it has to fit as an argument to a template.
So your scope is true lambda. You can put whatever you want in there.
That's right. You can have any sequence of statements in here. And that's where the C++ one kind of runs into a problem, is when you want to do something non-trivial in there.
Yeah, I mean, I feel like everything you've shown so far is boiled down to just that one point, is the awkwardness of doing lambda type expressions, arbitrary blocks of code in C++.
That's a big point.
Yeah, it is a big point.
That's true. In C++, you wind up doing it with the preprocessor macros and all kinds of overloaded templates, and it's just hard to see what's happening when you're looking at it. With this, it's actually very simple to see, simple to write, simple to understand, simple to see what's happening. And yes, you can do it in C++. It's just
I guess
not as easy to do.
I guess what my question would be is, if it boils down to one issue in C++, and these sorts of things are just the symptoms, why are these being addressed on an individual symptomatic level? Why is there, this scope thing, it's one example of something that boils down to the difficulty of doing lambda expressions in the other language. But, that you could enumerate any number of these that would boil down to the same thing. Why not address the core issue, and these things would fall out of it rather than having a bunch of just all these extra constructs?
Okay, that's a very good question, is when is something worth having a special construct for it, and when is it should be built up out of component parts, okay? That gets back to the thing I mentioned at the beginning of this, where it's the details that make a programming language easy to use. I believe that this is a fundamental construct. And as a fundamental construct, it should get the extra syntactic sugar that building it in the core language is able to provide for it. I have faith in this, that this will be recognized for being the fundamental construct that it is. It is not in common use now, but I believe it will be. As soon as people start realizing the benefits of doing it this way,
So the RAI has a lot of
syntactic sugar
benefits.
to make it work better. So you're right, it can be done out of components, but making it work better is important. I think, for a fundamental construct, just like the extra sugar, like for, for loops, while loops, and for each loops.
Just as long as it doesn't turn into pearl.
No, I don't think there's much chance.
I wouldn't accuse you.
Yes, sir.
The scope failure, the scope keyword, what's the generalization of that? Is there some, how does it work for a scope other than failure? I mean, what's the?
Okay, that's the next part now.
Okay.
So the gentleman behind you.
You said that this is a fundamental construct, but I thought you already had a fundamental construct that could perhaps enable this if you have lambdas. What you're basically doing here is constructing a lazy func and forcing it, and if it fails, it undoes itself, right? So could you not have, I mean, this basically looks like syntactic sugar to me.
It is.
So it's not fundamental then.
You could build it up out of lambdas,
Right.
and D does have lambdas. I just feel that this is such a fundamental issue that it merits having its own syntax for it.
Okay.
One nice thing about having its own syntax is code analyzers can recognize it instead of having to deduce it from the way you happen to write code. Does that make sense? Like, C doesn't actually have any construct that is loop over an array. It has a bunch of pieces you put together to loop over an array. And then what an optimizer does is it goes and looks at those pieces and through quite a fair amount of complicated processing figures out, oh, he's really iterating over a loop. Now I can do loop optimizations on it. But with a for each, the compiler already knows I've got a loop, I'm looping over all the elements. It's much simpler to do optimizations on it because you don't have to go through all this folderol to figure out that, oh, all he's doing is looping over a loop. With this, any code analysis tools will be able to see directly that, oh, he's using scope guard. I know what that is. I know what to do with it. Whereas if it's built up out of pieces, then it has to do a lot of analysis to figure that out. That's another advantage for a commonly used thing to get a bit of extra syntactic sugar help. So, do you have a...
Well, I was going to, does the programmer have any control over the execution order of the unwinds and the undos?
They happen in the reverse order they lexically appear.
So if you all right.
Now, as an implementation note, these are actually implemented by transforming them into the equivalent try-catch finalists. But they look so awful, you'd never want to write that code yourself. Okay, the two friends that go along with it are scope exit and scope success. Scope failure, that code gets executed whenever an exception, whenever a scope is exited via an exception. Scope exit works like finally, which means this code is executed whenever the scope exits, whether normally or whether by an exception. And scope success means execute this code if it exits normally, which is not through an exception.
Can you put expressions in there? Or is it only those three keywords?
It's only those three words. It's like in C++, you have the extern quote C quote. You know, there's 3 or 4 different words it recognizes.
Okay.
So it was done this way so there wouldn't be keyword proliferation, and then you could add more if you wanted to without screwing up anybody's variable names or anything like that. Okay, the next cool thing is lazy arguments, which came out of a long conversation with myself and Andre and Bartosz. The usual way that you do lazy stuff in C and C++ is the and, or, and question mark colon operator. They evaluate their first argument, and then they decide whether they're going to evaluate the second argument or not. And a typical use for this is if P is not null, then we can index P. So you look at that and you think, well, wouldn't it be nice if I could do that with function arguments? Because I don't always want to evaluate my function arguments. And let's look at a typical application, which would be the logging function. Lots of guys, or lots of code, you like to stick logging functions in there to see what's happening. and you pass it a lovely message to print out, and if my global logging switch is on, I write to my log file the message. Well, that's pretty straightforward. Nothing obviously wrong with it. And we use it like this. We go log entering my function foo with I equal to this value converted to a string. And that works. The ugly thing is the argument is always evaluated. Which, if you've got some fairly complicated logging code, well, you've got memory allocation going on, you got array concatenation, you got a lot of stuff going on, and then the value's just thrown away, it's never used. And that just, as someone who's interested in, making their code run as fast as possible, this is really irritating. So then we get to the usual C approach to fix it, is use a macro, like this. Well, as everyone knows, the preprocessor sucks. And there's got to be a better way. And the better way is using lazy arguments. We define all we do is we take our logging function and we just plop that keyword lazy in front of it. And that means it isn't evaluated until it's actually used. So here's the argument I pass. It's the same thing, except this argument isn't evaluated until right here. And what's happening here under the covers, which may make it a little easier to understand what's going on, is this actually is converted into a local function, or a nested function, or a lambda function, or a closure, or whatever you want to call it. And then what's actually passed is a pointer to a function, and then it calls the function there. Now you notice something, it's actually a little more than just a regular function, is it captures local variables too. And this actually is the coolest part of the whole thing, is I can capture my local variables just as if they're in scope.
Do I get to call that lambda multiple times inside my log function, or is it cached, or how does the...
If you place it multiple times, it gets called multiple times, which is actually kind of cool.
Yeah.
Because,
You can optimize for it.
in my next example, suppose I want to evaluate an expression count times, and the usual pattern is I write this lovely loop to execute my expression count number of times. And for those of you who are familiar with Lisp, we can do this. We can create a function called do times, count, and then my expression, which in the loop calls the expression, or I should say evaluates the expression. And then we can use it like our function foo in x equals 0. Do 10 times, execute this expression incrementing x each time. And we have a very Lispy looking thing that ends up printing this. Yes, sir.
So if the expression is not something that is going to have side effects, right, where you evaluate it 10 times and it's always the same result, do you have the overhead of calling that function that n times for if you're looping n times?
You can cache it.
Yeah, I mean, you could cache it, I guess, but you have to know that it's okay to cache, and detect side effects.
That would be a quality of implementation issue. If the compiler can determine that it has no side effects, yes, it can cache it.
Yeah.
The current compiler does not, though. It
That's
just,
what I was going to say. I mean, it's a quality of implementation, but if it's really difficult to implement, then it's a practical issue.
I don't think it's that difficult to implement. Okay, because you have inlining and all that stuff going on. I've expended no effort to try to implement this, or to try to implement caching with that. But you can also manually cache it if you want to. Just go, int y equals x, and then use y.
Yeah.
Yes, sir.
What is I'm tripping up a little bit on the lazy void expression, the void part of that.
Yeah. You want to wonder what the void means?
Yeah.
Okay, it means there's no value returned. Well, I don't care about the value of that expression. It's just an expression.
Okay, so, okay.
So it becomes a pointer to a function returning void. Okay, we can do some more complicated control structures like, you know, let's create a switch statement using this feature. Even though he already has a switch statement, this is a representation of how you can build a switch statement or a custom statement of your own design. So we have S-case, which basically is a replacement for if. So if B is true, then I execute my lazy expression and return bool. Then my conditional creates a collection, or actually an array of cases. And this is a bit of a, unfortunately, a bit of a kludgy syntax, whereas if I have this array of delegates, which are fat function pointers, it will take expressions and convert them into being delegates for me. And I loop over them like this. I can use it like this. And you see it's analogous to a switch statement. I call a conditional function and I pass it these lazy arguments, each of which is another call to a function that takes lazy arguments. And b equals 2 up there, so it should print it's 2. Which if you try it and it's not broken, it does actually print it's 2. Okay, here's another common pattern, whereas I have a variable called p and I initialize it with foo, and if it fails, I want to throw an exception. Otherwise, I want to use it. Now I have a problem because throws a statement. Those things need to be broken up into multiple statements, extra variables, and Andre and Petru have a paper called Enforcements on it, which explains all the why this is a nice thing to have. With lazy evaluation, we can implement it rather simply. Or there's our parameter, there's our message to throw for an exception if it fails. And our example becomes enforce call function foo. This message gets evaluated and turned into an exception and thrown if it fails. If the function returns normally, I can just go .bar. And I don't have to create extra variables. I don't need those extra statements. In fact, it's more likely I'm going to do this right because I can do it with a simple one-liner like that. So 5 lines of code become 1, and we can even make it a template function so it works with any type. And this version up here is specific to ABC. This version down here is generic for any type T. This is how you write a template function. In D, you just put parens for your types in front of the argument list. Okay, lambdas. Lambdas are function literals. For example, I have a function called foo. I'm passing it an array and another parameter, and I want to apply to each element of that array some operation. So this is my lambda function. It takes a parameter of double x, and it returns x times c. And here's my apply template, which loops over the array with a for each loop. Takes my sums my function f passing the value or the element of the array for each member of the loop, which executes that code up there, sums them all up, returns the results. So that's really all there is to lambda functions. And you can think of, like with floating point, let's say I wanted to create a function and do numerical integration. My f of x would be the lambda function. And in C++, you do this with expression templates. So you can do this in C++ too, if you are able to get expression templates to work or understand them, which I've always had problems with. Yes, sir?
And the lambda function is specified by reference or by value?
Is lambda function by reference or by value?
C.
No, and a C parameter is specified by reference or by value? How can you control it?
It's by reference. It is not made a copy of C is not made. You can actually change C within that function. Yes, sir.
So is C captured onto the heap such that that lambda function that could then be passed outside of its original stack scope, or?
So the question is the surrounding scope captured and put on the heap so that it survives the end of the function? And the answer is no. If you try to pass it, like install it into a global somewhere, or a reference to it into a global, it will fail just as if, like in C++, you return a pointer to a local. It will fail for exactly the same reasons. There's a future version of D probably will probably capture them, but the current version does not. So you've got to keep them, you can't allow them to escape the activation on the stack of the function. Okay, here's a fun thing. Tuples. Tuple is a list of types, a list of values, or any combination of types or values. And we create a tuple by going template tuple e ... means variadic arguments. So that means that the template accepts any kind of parameters in any order or any number of them. And we alias e tuple, which means that the name tuple with those arguments represents that list. So tuple bang, which means instantiate the template. Int long float creates a tuple of int long float, three types. Or we can have a tuple of the values 3, 7, and the character C, or a tuple of a type and a value. So we can refer to them symbolically instead of having to type the tuple thing over and over again, just by going alias, give the tuple, and we'll call it TP. So here we have 3 different tuples declared, and now that we have a handle for them, we can do some fun things with them. For example, tuples share a lot of characteristics of arrays, except they're completely compile time arrays. They're not runtime creatures, they're all compile time. So tp.length gives me the number of elements in the tuple, which would be 3. And here we can declare a tuple, or we can declare f, and we can extract the one element out of the tuple, which happens to be float, equals the value of the third parameter, which happens to be 3. So this declaration is the same as float f equals 3. We can also slice the tuple, which means I want to pick a group of elements out of it and give it another alias. So we go alias tp 0 to length minus 1 tq, which creates the tuple float comma float. Because what this does is it chops off the last element of the tuple. Okay, tuples are completely compile time, which means I has to be evaluatable at compile time, so this is going to fail because the compiler doesn't know what I is at compile time. Yes, sir.
You could steal a trick from Perl and say that negative indices are always relative to the end of the array.
Boo.
You know, lots of people come up with Perl-like suggestions, and they usually get booed down. I actually implemented some Perl stuff in V once, and there was a firestorm of, we don't want this to be Perl, so it got removed. So, V is not Perl, although you can do a lot of Perl-like things in it. It's not gonna, it doesn't look like Perl, doesn't act like Perl. Yes, sir.
So that alias keyword over there, is that going to copy the array into TQ, or is it going to refer to the same source, TP, for those elements mentioned there?
Alias creates a symbolic reference to it. Just like in the Unix file system, I create symbolic links to files. Alias works like that. It just says, you know, create another name for this object over here. So an alias is a compile time creature. But it's very handy because I can rename things, I can give things new names, I can move them around in different scopes by just creating aliases, just like I can on the Unix file system by using symlinks. Okay, here's a thing that you'll do if you want to manipulate tuples. Most of the algorithms involve dealing with the head and the tail. So the head is trivial, it's DP, first element. And the tail is also trivial, it's 1. It's a slice of 1 followed by, or to the end of the tuple.
How does that work with elements that only have one?
Compile error. Yes, it does overflow checking at compile time. You can't screw it up.
I'm a little confused. TP.length at the top line of the screen shows 3. Then the third line, alias TP 0 ... length minus 1 would be 0 to 2, which sounds like 0, 1, 2, 3 elements, but you've shown 2 elements.
Okay, when you're doing slicing, the first index is inclusive, the second index is exclusive. And it sounds wrong at first, but if you use it for a while, it feels natural, and every other way of doing it feels all wrong.
What square brackets mean? Inclusive.
Wow.
I mean, symmetric, right? Why would you interpret it one way than the other one?
Mathematically, you're correct, but people who programmed in C, that's not the way it works. And the indexing works like it does in C. Whereas if you index with the length of the array, you're off the end of the array. Yes,
And the principal answer to that is that the brackets in that context do not denote the interval, but they denote the substrate expression. The interval is punctuated only by ...
Okay. Sir?
Why is the exclamation point necessary? What happened? You said it was to instantiate the template. So
Okay.
you leave it out and it doesn't get instantiated and you get a link error, or what?
Okay, in C++, templates have less than and greater than brackets.
Yeah.
Okay, those cause endless and years and probably 1 million man-hours of grief. What D does is exclamation mark paren is a replacement for the greater than, less than.
I'm just trying to, I mean, you've already declared tuple as a template, right? Is there some other syntax, like if you left that exclamation point out, you just have tuple and some parentheses. Would that conflict with something else so that we need the exclamation point to disambiguate, or what?
Okay, it is needed to disambiguate. For example, if it's a function template, you have to know whether you're passing arguments to the template or arguments to the function.
I see.
And also, if you just leave it as parentheses, even if you could disambiguate it, I bet you down the road it's going to cause problems. Because too many different uses for parentheses just kind of, it gets too messy.
So how about a different kind of bracket beside parentheses? You know, there's these angle ones. I'm just saying, I mean, angle brackets, right, as opposed to brackets made of, on one side you've got an exclamation point and a parenthesis, on the other side you've got a parenthesis. I prefer the angle brackets.
Okay.
Except that they also mean less than or greater than or left shift or whatever.
Use Unicode.
That's a very good point. And believe you me and a bunch of other people have gone over the keyboard over and over and over again and have written things out. That works the best. And it does look funny at first, but you rapidly get very used to it. And the other thing is I never got used to that because it always to me looked like less than greater than. Like if you take an IO streams expressions with C out and the angle brackets and templates and blah, 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 you look at it and after a while it just looks like, angle bracket hell. You can't figure out where the templates start, where the less than starts, where the shift operator ends.
You can use any syntax.
It's just horrible. This is easy for the compiler to parse. It's unambiguous, and after your eye gets used to it, because it's not angle brackets, it starts getting easier for your eye to parse too. It really does. It's one of those things where you try it, and I think you'll like it.
I mean, I assume it's subjective because I could say the same to you about angle brackets and you disagree, but.
I disagree. I've used them for years and never ever got used to them.
But I might use this for years and never get used to it.
That's possible.
I don't plan to.
Everybody's different.
Yeah.
Sir.
I'm curious about how they aggregate. In the top example there, you've got the TPTR, and then the TP length and some examples. So would you go over real quick what happens if you have the TR and the TS?
Okay. TR.length will give you 2. TR sub 1 will give you 8, which will give you a syntax error because 8 space F is not, you have to have a type, not a value, to declare a variable. And TR sub 2 will give you an error because that accesses the third element, and there are only 2 elements in it. On the next line, if you go TR sub 0 length minus 1, TQ.
So when they aggregate, it's like a multi-dimension. Right.
I'm sorry, I screwed up. Let me back up. That's a very good point. I screwed up my own slide. Okay. TR is composed of the tuple TP, comma 8. Tuples don't nest. You cannot have a tuple of tuples. So what happens is the tuple is expanded, or as, unpacked is another word for it, in place, and TR becomes a tuple float, comma, 3, comma, 8. So it actually becomes a 4-element tuple. And TP, comma, TP becomes a 6-element tuple. Float, float, 3, float, float, 3. So you cannot have a tuple of tuples. Yes?
Can you use for each on tuples?
Yes, you can. That's coming up. You can do all kinds of this horrible stuff with tuples. The fellow behind Andre raised his hand first.
I would like to see how you would allocate the tuple on heap with new.
It's a compile time thing.
I know, but is there any dynamic features of it?
Yes, there is. And I think that's covered later in the slide, and if it's not, remind me and I will show you how to do that. Okay, I think there we did head and tail. Okay, so the guy who really did tuples in C++ is Andre in his seminal book, Modern C++ Design, and he has a whole bunch of algorithms based on tuples. Yes?
I think I'll count about the angle brackets real quick. Apparently, they successfully deter many people from writing advanced template code because there are many advanced idioms that people simply can't get right because the compiler keeps on making the confusion between less than and introduction of a template. So they would have to stick the template keyword in, but 99% of the people, even those who've used C++ for years, have no idea that that's needed. So they simply give up on using advanced C++ idioms. And so the problem is much deeper than it would seem like at first sight. So it's not a matter of just putting a parenthesis around stuff, and it's just not that. They don't pair. Angle brackets don't pair, they will never pair.
Okay, I hadn't realized that. For some strange reason, both C# and Java went to the angle bracket approach, and they're going to fall into the same hole as C++ did sooner or later. I think the reason they haven't fallen into the hole is they have very primitive template systems. But as soon as they try more advanced things, it's going to screw up for them. They should have gone to this approach. Okay, erase is one of the algorithms, classic algorithms that you can do with tuples. And what it does is, if I'm given a tuple TL as my second argument, I want to return a tuple that is the second tuple without the first occurrence of the first type in it. So I want to erase the first type from the tuple. And here's how I implement that template, which actually has more comments than code, but okay. I'm going to get to static if later, so bear with me. This is what a static if does, and it works like hash if, except it's built into the language, it's not a preprocessor thing. So static if the length is 0, then my return tuple is going to have 0 elements, because if I erase something from a 0 or an empty tuple, the result is an empty tuple. The next thing is, if my type is at the head of the tuple, then I return the tail of the tuple, which is what this does. It creates a slice of the tuple of whatever's left and returns that. Otherwise, no match. So I return the head of the tail concatenated with the recursive erase of the tail, which is, here's the head of the tail, and then I try to erase the type out of the rest of the tuple, and that's the result. You can do this in C++. It's an awful lot of code to make this work, mainly because C++ doesn't support variadic templates. Yes, sir.
You said the static if is a compile time if.
That's correct. You can actually use static if to wrap declarations and statements and anything else. And it does not introduce a new scope. It works like hash if, except it has access to the symbol tip. And I'll go into that in more detail a little later. Okay, so far we've dealt with tuples, which have only types in them, and those are called type. Another word for that is type lists. Okay, function parameter lists are also lists of types, and so a type tuple can represent a function parameter list or can be extracted from a function. So this rather strange syntax is just a way to get TP to be a tuple it, log. So this is actually encapsulated into a template because it is kind of ugly syntax, where I can just go alias parameter type tuple, this is part of the standard library, bang, pass it the name of my function, and I get a tuple of the parameter list, or the parameter types of the function. And we can use them to declare another function. So now I can go float bar with my tuple, and I've declared a function which has parameters in log. So what this actually is a reflection, compile time reflection. Okay, we can also, if we're doing implicit function template instantiation, we can also deduce tuples from the function templates. So there's my function foo with 2 parameters, and I have a template function called bar, which has a return type and tuple type deduced from my parameters, which is the return type, function pointer, parameter types. And I can write out what they are. I can write my return type is the type of R, and my parameter types the type of G. And if I call it bar address of foo, address of my function, it will actually print return type equals int, parameter types are int, log. Expression tuples are tuples that are all expressions. So I can create an expression tuple that is 3, 7 long, 6.8. And if I write it out using my, D's replacement for printout, it'll print 376.8, which is 376.8. I can pick out the second element, print that. I can pick out a slice and print that.
Question.
Yes, sir.
The printout is ambiguous. I mean, it could be 30, I don't know, some other number, right? It's not a one-to-one relationship between what you specified in the declaration. Does that not bother you?
I don't understand.
You need
Let's say the
spaces.
first number is 1, 2, 3, right?
Yeah.
You could print it out as 12376.8, but it could have been, 123768. So it's not unique.
He wants delimiters. There's no delimiters between your 3 and your 7.
Oh, yeah. Well, that's because I'm trying to squish the thing in so I can make the font bigger. But you can actually use right-f line, just like with printf, you can use it to insert delimiters between the arguments. And then you would get, 3, 7, 6.8 if you want. So yes, you can do it that way if you want.
So you could write a template that takes a tuple and inserts spaces.
Yes. Can I do that without thinking about it? Probably not. Yes?
Another question. In other languages where tuples exist, people typically move on to record types after the tuple grows to either 1 or 2 or 3 elements with labels. They say, why is there so much emphasis on tuples in D? I mean, there's functions to manipulate them, etc. What's the
Because
point?
you can do so many cool things with tuples, I guess is my only answer. Andre?
So reflection would be the most important one. And the other would be like modern C++ design, which arguably you could say does work, does maybe 2/3 of its work based on tuples alone, on type list actually. So you could take straight, like maybe with one exception, all designs in modern C++ design and translate them in D much easier because of tuples alone.
Okay, there's one example. I'll give another example of the value of tuples. So is anybody familiar with Trolltech's Qt? Yeah. Okay. Qt works with C++ by applying a preprocessor that compiles a C++, figures out what's going on, and then it generates the code. You can do that in D with about 100 lines of code using tuples. And you can pretty much duplicate the whole signals and slots thing with about 100 lines of D code instead of requiring you to build an entire compiler to get it to work. So that's one example of the value of it. Another advanced thing you can do with tuples is like function currying, which is valuable for certain kinds of programming paradigms. And it's really, really hard to do without tuples. And with tuples, it's easy. So there's just 2 uses of tuples. So imagine all the man hours that Qt could have saved if they didn't have to write a C++ compiler just to be able to implement signals and slots. Yes, sir.
I would also add that it looks kind of compiler support for the variant type of the variables with tuples.
Yes, I think you can make that work. Okay, you can use tuples to create an array literal if you want. Array literals in D have square brackets around the list of values. Okay, so here we get some more fun stuff. The .tuple of property turns fields of a structure or class into expression tuples, which means I can get at what's inside a struct. So this gets back to what you said about how do I allocate a tuple. What I do is I put a tuple inside a struct, or wrap it with a struct, and then I can allocate the struct. So here I have a struct S, which has 2 members. And foo, which has int a, long v, and prints its arguments. Here's the usual way to call it, foo s dot x, s dot y. That's pretty standard. Well, you can go s dot tuple of is exactly the same thing. It'll pass it s dot x and x dot y. I can also reference my members using the array syntax. So I can get at the second field, I can get at the first field. And if I go off the end, I get a compile timer. I can also do the reverse operation. I don't have a slide for that. But if I can take a struct S and I can give it a field declaration using a tuple, and it will declare, like if I give it a tuple of float comma int, it will declare two fields, one float, one int in there. So I can go both directions. Yes, sir?
Will that work if 7 and 8 weren't literals? Or is it still just compile time?
Yeah, it'll work. Yeah. Yes, sir?
When you construct the struct from a tuple, what are the names of fields?
You go, the tuple TP x. So then it would be x sub 0, x sub 1 will be the names of the fields.
They won't have normal names like they will here.
Yeah, well, instead of int, I would go TP for with my tuple name. I go TPX semicolon. And then to get access to the first element, I go x angle bracket 0 angle bracket, square bracket. So I'm basically using array syntax to grab the nth field. Okay, I can also, just simply print out the types of all the fields in my struct. Now, this is handy if you're trying to write generic code to do things like roll your data out to disks. It's compiled, again, it's compile time reflection of what's inside the struct. There was a question before about, can I do a for each over a tuple? And yep. For example, let's create a tuple that's an int long float, call it TL. And for each, I is the index, T becomes the type of the tuple. So what happens is this loop is unrolled 3 times. Each time T is set to be an alias of first int, then long, then float. And I can go, my index here equals there. And I can do it again with values. There I did it with types, here I did it with values. And this is unwound once for each element of the tuple, and it will print this. Int long float 376.8. This is one of those things I was just working with the tuples in the compiler and I realized that I can do this. Really neat. Okay, a variable declared with a type tuple type becomes an expression tuple. So I have my int long TL, and I declare my function foo with this type list of T1. And here I can write out T1, which is both arguments, or the second argument. And then, if I pass foo 1, 6, it'll print out 1, 6, 6. And of course, I could modify it to put the commas in, but this example doesn't have that. So in the same way that I can use a tuple to declare the fields of a struct, I can use it to declare the arguments or the parameters to a function. Okay, here's an example of print print in C has always been a little bit broken, because what I'd really like to do is I'd like to print 7 character array followed by 6.8. I don't want to have to put a format string, I don't want to have to tell it what the types are, and I want it to be efficient. So here's how you do it in C++. I create this template called print, and I create lots and lots of print templates. One for one argument, one for 2 arguments, one for 3 arguments, and I've seen it go up as far as up to 50 arguments, which makes for an awful lot of code. The problem with that code, of course, is you have to decide in advance what's the maximum number of arguments you're going to have. Your logic has to be cut and paste, duplicated, then modified, and if you're like me and you're modifying all this code, I'll get some of those numbers wrong, and I'll have A2 printed out twice and A3 not printed out at all. That's a popular bug in my code. There's no obvious connection between the various template function overloads and, of course, load. And Douglas Dreger has proposed a C++ extension to add variadic templates to C++, and it works like this, where the print template loops, picking off the first argument, printing it, and then reinstantiating itself for the remainder of the arguments. And we can translate that into D, and it looks like this. Almost exactly the same. But we can do better. Print is a template function that takes a variadic number of arguments. We loop over the array of elements, printing out each one. And I like that a lot better than even the proposed C++ solution. Okay, mixins are a variation on, yes sir?
About printing, how do you print out custom data types?
By function overload.
What if it's not defined?
If it's not defined, well, then you'll get an overload mismatch.
Okay.
Mixins are a way to add boilerplate declarations, and they look a lot like templates. In fact, the syntax is identical to templates. I have a template foo, and I have a declaration in it. And I go mixin foo. And what it'll do is declare an int variable x and set it to 5 in my current scope. Or I can mixin foo in there, and it'll create a field called x, a type int, initialized to 5 for struct. And the mixins are very handy if you're creating a bunch of boilerplate for a bunch of templates or structs. So, I got test. I can also mix it in as a local variable, print it out, and it'll print out x. X is declared, and print out 5. I can parameterize them with the type t. And this statement here will declare an x of type int. I can use mixins to add virtual functions to a class. There's a mixin that declares a function, prints out foo.func. Class var, which mixes in foo. Class code :var, which mixes in a virtual function that overrides it. And if I create a bar, it'll call the mixed-in foo.func. And calls the overrated one, usually polymorphic. It's just a way to insert boilerplate code. Mixins are evaluated in the scope of where they appear, not the scope of the template declaration, and this is illustrated by this example. I declare a global y, and I have a mixin, which is a function which returns the value of y. Inside test, I declare another variable called y instead of 8, mixin foo, then I call the function ABC and verify that it's returning 8, which means this y has picked up this variable, not that variable. Which shows that this is evaluated here. It's not evaluated here. Under.
The point you mentioned that your templates do the exact opposite, and that is important.
Okay, the difference between mixins and templates, very good point, is where they're evaluated is complete opposite. Templates are evaluated where they are defined. Mixins are evaluated where they're instantiated. And sometimes this causes confusion because people expect it to work the other way. C++, sometimes it's evaluated where it's instantiated and sometimes where it's defined, and it's called that two-level dependent and independent name level lookup, which confuses everybody. I can even have a mixin parameter using symbolic parameters. And I call that, it's called an alias parameter. Return B, whatever B happens to be. And here, I'm passing it Y, which is this variable, and ABC returns the value of Y.
So,
And it's passed symbolically, not by value, not by reference, it's passed symbolically. Yes, sir.
so I guess that kind of did answer my question. If there was a way, though, that you wanted to do it by value, you would have to, is there any way to capture its value?
Yes. Instead of alias B, you say int B, and then it will copy its value. So that's one difference between D templates and C++ templates. Is C++ templates, there is no pass symbolically. It's always passed by value or passed by type. In D, you can pass symbolically, which turns out to have a lot of cool things you can do with that. Okay, the last thing is static ifs. So let's look at some C code, which hash defines foo as 1 because, you know, that's my feature. My feature foo, I turn it on by setting it to be 1. If foo, I declare j to be an int. Otherwise, I declare j to be a long, and I return j plus I. In D, I can do it this way. Unless there's no separate macro language, it's all static ifs can reference my locals or your local symbol table. As long as it can figure out what it is at compile time, it'll work. So obviously j will be an int, and this won't happen. Now the important difference between static if and if is static if does not introduce a new scope, which means I can declare variables in it, and those variables live after the static if is done. Yes, sir.
Could you change the function's return type the same way?
No, you would have to duplicate the function. But what you could do is you could make the return type an alias, which is a type def in C, and use the static if to set that alias to the right value, and then use the alias name as the function return type. And the reason for that is static if is a statement type, which means that you cannot mix it in the middle of an expression or in the middle of a declaration. It's not a preprocessor thing. Yes, sir.
Can they occur outside of the function scope?
Yes, they can, in which case they're a declaration type.
And is it a mistake that the return type is void, or am I missing something?
Yes, that's a mistake.
Okay, thank you. That's why you wanted to change it.
Just there to see if everyone's awake, yeah. It's my excuse. That's what I get for making the presentation yesterday. Okay, static if, that's kind of a, pretty boring, straightforward stuff. Where static if really starts to work is in templates. It turns out that in C++ templates you have hash if, but it doesn't work for templates because hash if expressions cannot access the template arguments. They don't know anything about the template arguments. So how C++ gets around it is a C++ template metaprogramming is a pure functional language. And so you use functions with, or template functions with partial specialization to do the equivalent of your ifs. So you wind up with a whole bunch of templates to do something simple. So here's a simple, this one actually in the angle bracket showed up. This is the usual factorial C++ template, which recursively calls itself to compute factorial at compile time, and it has two templates. And the whole reason for two templates is to find a way to stop the recursion by taking advantage of partial specialization. So, you know, if we factorial of 4 gives 24 as a result. You can do that code in D if you want to, because partial specialization works in D templates too, and this is the equivalent code, does exactly the same thing. But if we use the static if, we can do it with one template, which is if n equals 1, our result is 1. Otherwise, our result is recursively call ourselves. So when you have a whole bunch of if statements, you get, you know, a dramatically clearer and shorter code with the static if than you do using the functional notation. So there's some more things we can do with static ifs. C++, you can't have a floating point value as a template argument, but you can in D. So we can create a square root template that computes a square root at compile time. And there's a problem. You can't declare compile time variables, but you can fake it pretty good indeed by using parameters. So our square root takes x, which is the thing we're going to try to find the square root of. It takes the second variable, which is our current value that we're, you know, how far we've gotten, and the third parameter is the number of tries we've done so far. And the default value of our first guess at a root is, you know, x over 2, and number of tries is 0. So the first thing we check, if the number of tries is 5, we give up and say that our result is our current value, our last attempt at it. Otherwise, if the root squared minus x equals 0, we've got an exact match. Otherwise, we try again. Recursively call x root plus x over root over 2, which I believe is called Newton's method, and we increment the number of tries.
So have you had any numerical people say anything about that? There's a good reason why floating point constants don't work. This code depends on where the code was compiled. Root times root minus x equals 0
Yep.
is not valid floating point code. Because equal is not a, floating point isn't accurate.
Right. That's why there's the number of tries equals
Right.
5.
So
because
your code
it
here,
turns out, for real precision, that if you do it 5 times, you're going to get the right answer.
yeah, your code here works, but there are plenty of applications where the equality operator is that's nonsense in floating point code. You have to use an epsilon.
Okay.
And so you've done epsilon effectively by using n tries, but
That's right.
that's why C++ doesn't use floating point, because a floating point constant really depends on either the host, or you'd have to have a pretty impressive interpreter that makes sure that all the bits are the way the machine that's going to be executing the code interprets them.
Well, I think that's an unnecessary restriction of C++ because there's a lot of things you can do with floating point arguments and templates. And C++ completely misses the boat. I think part of that is because C++ doesn't even specify that the floating point is supposed to be IEEE 754.
That's true.
So anyhow, and I checked this on my calculator. If I pass it square root of 2, it actually prints this out, which actually matches exactly what my calculator says the square root is. So it does work. Yes, sir.
What kind of expressions can you have in a static if?
Anything that can be computed at compile time.
Could you call functions from other modules?
Currently, they can't be computed at compile time.
Okay.
Future implementations, it's definitely possible, like if they're pure functions. You know, if the functions have those side effects, don't access global variables, whatever, they can be computed at compile time. And that's one of the things that, you know, we've been talking about for 2.0 is support for pure functions. Once that gets in, then yes, you can do functions. Here's another lovely thing. Not only can I do floating points as template parameters, I can have string literals as template parameters, which means it's possible I can compute a hash of my string at compile time, which is handy for building my keyword symbol table, let's say in a parser. Instead of having to load up the table at runtime, I can build my table at loading the table at runtime. I can load up the table with the correctly computed hash values at compile time. So here's how I do that. If the length is 0, then my hash is whatever I've computed so far, which defaults to 0. Otherwise, hash is, and it recursively calls itself with the tail of the string, which from tuples is the same syntax, 1 dot dot length. Otherwise, my hash function is so far times some prime number plus the first character of the string. And that does a nice little hash. And so I can return the hash of hello world, and hello world doesn't even get stored in the program anywhere. You just get the value of the hash value. And that's the end of my presentation. Yes, sir.
I suspect I know the answer to this, but is this an adult programming language in that the compiler is written in itself?
Okay, is the compiler written in D? Because if it's not written in D, it's not a real language. The compiler is written in C++. So why is it written in C++? And that's because the back end that I have is written in C++. And although you can connect D directly to C code, you can't connect it to C++ code without building C wrappers for your C++ code. The second reason is it isn't just my compiler. It needs to hook up to any compiler vendor who's got an optimizer in the back end. And what's the most likely language it's written in? C++. So in the interest of making it easy to proliferate, it's written in C++. So I find myself constantly when I'm writing going, I'd really rather be writing this in D. It would be a lot less work. That's not good.
You could write the front end in D at least, right?
What?
You could write the front end in D, wouldn't you?
Well, then I have to have some conversion to C++ for the intermediate, the functions that represent the intermediate code. However, I will say that the runtime is written in D, including garbage collector. So if you can write a garbage collector in D and have it work just as well as the one written in C, then I think that proves the point that yes, you can do high performance code in D just as good as you can do it in C. In fact, I would argue better because D has an inline assembler as a defined part of the language instead of an optional, add-in. Some people argue that C and C++ have inline assembler. Well, if you look at the standard, it says all it has is asm string. It doesn't say what that string does. It could be, launch the nuclear missiles. I would argue that that's not support for inline assembly.
Are you saying D can't launch nuclear missiles?
Definitely, that would cause a seg fault. Hopefully it will cause an assertion failure, yes. Yes, sir.
So you've got some nice stuff for dealing with exceptions. Do you talk any more about threading than C++ does?
Threading is, to be resolved, and I know that the C++ group is working really hard on trying to figure out the right way to do threads in C++, and since the guys working on it know a lot more about threading than I am, I'm kind of going to let them do the hard work, and then going to look and see the results and see what can be adopted from it. I just don't know threading that well. And those guys really, really understand threading. I've listened to them talk about it, and they know what they're doing. And so I think they're going to do some really cool stuff for C++. So, yes, sir.
I know as the language designer, you want, to some degree, I think you want to stay agnostic to what people use particular features for primarily. But the tuples stuff is interesting to me, and I wondered if you intended that more for solving problems of writing a standard library in a nice generic way, or other applications in generic algorithms, generic containers, things like that, or more for tool and framework support, like Java reflection is used heavily to take something that somebody else built and introspect what's in it, and then go do something interesting with it. Is it
It's
one
not,
or the other in mind?
It's not really intended for any one thing. It was sort of build it and they will come. And I've been amazed at what people have been able to do with templates in just the short time it's been available. A lot of people weren't, before the tuple support, people would look at the D templates and go, yeah, it's easier to use in C++, and yeah, it's kind of cool, and yeah, it's okay, but with the tuple stuff, it's like, oh my God, now I can do what I really want to do with templates. It's sort of like, it was kind of an enabling feature, if that makes sense. If that makes sense, it enables a whole bunch of new kinds of things you can do. Like the single signals and slots becomes almost trivial, whereas before it's disastrously difficult to do in C++. Boost has made an attempt to do it, but just look how complicated the Boost implementation is. Yes, sir.
I noticed that you don't require the static keyword on for each that iterates over tuples. Is that why you chose a different syntax for tuple for each and gave us the index, whereas you don't on the runtime for each?
On the runtime for each, you can also get the index if you put it on there. It's not a different syntax.
So they have the exact same syntax?
The exact same syntax. What for each won't do right now is you can't create declarations with for each. So there's going to be eventually a static for each so that you can create a whole bunch of declarations based on the tuples. Like you can with static if, you can create declarations that exist past the end of the static if. Well, with for each you can't do that because it creates a new scope. So there needs to be a static for each so that things will survive past the end of the for each. And that's one of the future things that's planned. It's just kind of the next logical step. Another thing that tuples can't do right now is you can't return tuples from a function, and that's something that I really want to get fixed because that makes tuples really cool. Right now, the only way to do that is embed the tuple inside of a struct and then return a struct. More questions? Okay.